Hi friends, welcome to Curie Electronics. Today we are going to solve Technician B Electronics question paper VSSC 2015. So please share the video with your friends. Also please press the bell icon for notifications. So let's start. The first question. The curve represented first question. The curve representing Ohm's law is. What is Ohm's law? Ohm's law says voltage is directly proportional to current. So if you draw a plot between the voltage and current, if you draw a plot, this is current and this is voltage, we will get a straight line like this. So the answer is linear. The curve representing Ohm's law is linear. Second question. As the frequency increases, the capacitive reactance of the circuit. What happens to the capacitive reactance? What is the equation for capacitive reactance? That is Xc. Xc equals 1 by 1 upon 2 pi Fc. So here with the frequency increases, this is the Xc value. Xc decreases with increasing frequency because frequency term is coming in the denominator. So frequency decreases, not frequency. With increase in frequency, our Xc value decreases. So the answer is option A, decreases. Now what if it is inductor? What happens if it is inductor? Inductive reactance, that is XL. XL equal to 2 pi Fc. Here when frequency increases, XL or inductive reactance also increases. So next question is a RL circuit has 6 ohms resistance and 8 ohms inductive reactance. Its impedance will be. What is the equation for impedance? C equals square root of R square plus XL square. So what is the value of R? R equal to 6 square plus inductive reactance equal to 8 square under root. So it comes to 36 plus 64, which equal to under root 100, which equal to 10 ohm. So the impedance will be 10 ohm. Answer option C. Next question number 4. Surface area of a cube with side A is. So this is a cube. Cube has got how many sides? See 1, 2, 3 and the other 3. So total 6 sides are there for a cube. 6 sides are there for a cube. Now, if you take this side, he is saying all sides of A, each side equal to A. What is area? What is the area of a square? A is also A, so it equal to area. Area equal to A square, A multiplied by A. Here similarly, similar way we have 6 squares, that is 6 multiplied by area of 6 sides. So 6A square, that is 6A square. So the answer is option A. Question number 5. In an oscillator, the feedback signal is in phase with the input signal, in phase with the output signal, out of phase with the input signal, out of phase with the output signal. To make an oscillator, our input signal, if this is our input, our feedback also should be in the same phase, then only the circuit oscillates. So the answer is in phase with the input signal. Question number 6. The peak inverse voltage of a full wave bridge rectifier is peak inverse voltage of a full wave bridge type. It is Vm. It is Vm. So this is a Vm. This is Vm. See, this table shows the comparison of half wave bridgifier, center tap rectifier, and bridge type rectifier. Now, how many? We will just go through it once. How many diodes are used in a half wave rectifier? That is 1. If it is center tap, we need two diodes, and the output side center tap will be act as a ground. If it is a bridge rectifier, we need 4 diodes. In half wave, center tap is not necessary. Full bridge also, center tap is not necessary. We can take the 220 volt and rectify it. But in the center tap, transformer is must. Then what is the efficiency? Efficiency is high for a bridge type as well as center tap. This both efficiency is equal. For center tap rectifier and the bridge rectifier, efficiency is same. That is 81.2%. For a half wave rectifier, only half of that we will get it. That is 40.6. Now there is a ripple factor. What is the ripple factor in a full wave rectifier? Ripple factor is less. That is just 0.48, which also equal for center tap as well as the full wave bridge. The ripple factor of half wave bridge is higher than 1. That is 1.21. Output frequency. For a half wave rectifier, output frequency is whatever the input frequency. In center tap, it is 2 times the center frequency. In a bridge rectifier also 2 times the center frequency. See, the rectifier gives a output which will have a AC content of 2 times the input frequency. That means if you give a 50 Hertz, we will get 100 Hertz ripple in a full wave bridge rectifier and center tap bridge rectifier. But here we will get the half wave, we will get 50 Hertz itself. Now this peak inverse voltage, where we consider this peak inverse voltage, when we want to choose the diode. See, when we want to choose a diode, if we are using a center tap bridge rectifier, we have to see the peak inverse voltage. At least you should have 2 times the maximum voltage. So the peak inverse voltage of a full wave bridge rectifier is Vm. That is one of the advantage when it is compared with the center tap rectifier. Question number 7. The output impedance of an ideal operational amplifier is. For an output for an this is the operational amplifier symbol. This is the non-inverting input, and this is the inverting input, and this is the output. So here there's a comparison of ideal and typical values of op-amp parameters. What is the loop? First parameter is DC open loop gain. In open loop gain means there is no feedback. Without any feedback in the loop, the gain of ideal op-amp is infinite, but it is around 10 to the power 5 in reality. An op-amp should have input impedance of infinity. Why we will say we should have impedance of high value? Because then it doesn't load the driver. Okay, this is in practically it is almost 2 mega ohm. What is the output impedance of an op-amp? That is ideally 0, but normally it is 50 to 75 ohms. Okay, then one more common mode rejection ratio. Common mode CMM, common mode rejection ratio. This is the ratio of differential gain to common mode gain, which is actually infinity for an ideal op-amp, but it is around 90 dB practically. So the question is, the output impedance of an ideal operational amplifier is. Output impedance is very low, not very low, it is 0. See, take care of very low and 0, it is 0 ideally, but if it was a practical op-amp, answer is very low. Question number 8. The voltage gain of an amplifier is 100 on applying negative feedback with B equal to 0.03 is gain. With the negative feedback, that is 100 multiplied by what is the factor, multiplying factor, 0.03, which equals 3. So the answer is option C, 3. Question number 9. The calibration signal usually available for CRO is of the type. In every CRO there is a option it will provide a test signal so that we can verify whether oscilloscope is our probe is working properly or measurements are happening or not. Usually all oscilloscopes provides a square wave voltage. So the answer is option B, square wave. Question number 10. A triac can be considered as a combination of Triac. See, we use Triac to control AC, that is alternating. We use Triac to control AC, so the both direction control has to be there. So see, this is the symbol for Triac. This is the symbol for Triac. This is the symbol for Triac. Triac has got two main terminals, MT1 and MT2. So this is the and gate. Using the gate we can control the Triac. So this Triac is equivalent to two SCR connected back to back. See, as shown here, this is connected two SCRs connected back to back. See here, two gates are connected together. And one anode and one cathode sides are connected. Okay, so the answer is 2 SERs. Question number 11. A light dependent resistor or LDR behaves like, see in the market there is a LDR is available. LDR looks like a LDR. So like we can see here, when light, what happens normally in the darkness, if you measure the resistance, it may be 100 kilo ohm. When light falls on it, it just goes to, suddenly it goes to 1 kilo ohm when light falls on it. This is the darkness, and when light falls on it, suddenly the resistance drops. That is, it acts like a switch. Okay, if it is a high quality one, it may goes to 100 ohm. So from a 1 meg to 100 ohm. So it is acting like a switch. So the answer is switch. Question number 12. A rod of length 60 centimeter is bent to form a rectangle. One side is 10 centimeter. The other side is, see, we have a rod. Oh, sorry. We have a rod. This length is 60 centimeter, and he has folded it. He has folded and form a rectangle. And one side is telling 10 centimeter. If this is 10 centimeter, the other side will be 10 centimeter. So 60 minus 20, we are left with 40. 40 will be one side, so each side will be equal to 20 centimeter. 20 centimeter. The other side is, so the answer is option B, 20 centimeter. Question number 13. Thermistor is a transducer which converts thermist conduct heat temperature to thermistor is a transducer which converts temperature into signal. Temperature into signal. Okay, now what is a thermocouple? What is a thermocouple? What is a thermocouple? See, thermocouple. See, if we take one metal, see, this is a metal. We take it as copper, and copper is joined here. This is both side is joined. This we take it as iron, Fe. Fe. Now, if we heat this, if we apply heat here, and cold here, electricity is produced. This produces electricity. Electricity. This is what thermocouple does, and it works on the principle of, what principle it works? The thermocouple works on the principle of Seebeck effect, and this is known as a Seebeck effect. Okay, now we'll go for the next question. 14. Question number 14. If three 30 microfarad capacitor are connected in series, the net capacitance. Connected in series, the net capacitance. So what happens if three resistors are connected in parallel? What happens if three resistors are connected in parallel? What happens? Three resistors are connected in parallel. Each are 30 ohm. 30 ohm. 30 ohm. What happens? We will get a equivalent resistance of value of single resistor divided by total number of resistors. So we'll get a 10 ohm resistor. The similar way, if three capacitors are connected in parallel, capacitors are connected in series, similar way we will get, these are 30 microfarad. Each capacitors are 30 microfarad. 30 microfarad. If we connect, then our equivalent, C equivalent will be 30 microfarad divided by 3. So it will be 10 microfarad. So the answer is option A, 10 microfarad. Question number 15. 1 ampere. 1 ampere means what? What is current flow? I equal to dq by dt. That is, current is given as 1 ampere of current, 1 ampere of 1 coulomb. 1 coulomb should flow in 1 second. Okay. Now what is the question? 1 ampere means the flow of 1 coulomb charge each second. Each second. So the answer is option B. Question number 16. The charge in a C is 4 microfarad capacitor charged to 100 volt will be. What is the value of C? 4 microfarad. 4 microfarad. And V equal to 100 volt. 100 volt. What is the equation for Q? Q charge equal to capacitor into potential. So which equal to C is 4 microfarad. 4 microfarad multiplied by 100. So it is 400 microcoulomb. 400 microcoulomb. So the answer is option B. So friends, please share my videos with your friends so that everyone will be get benefited from it. And if you have any particular, if you like to see videos on any particular topic, or if you feel difficulty in any particular topic, please let me know in the comment section so that I will upload it for you. Now, question number 17. The unit of magnetic flux is, what is the unit of magnetic flux? See, Weber also a unit of magnetic flux. Maxwell also a unit of magnetic flux. But for this question, the answer is Weber. Weber is the modern unit, that is the SI unit. This is the CGS unit. So always go with the Weber. There's a relation also. 1 Weber equal to 10 to the power 8 Maxwell. 10 to the power 8 Maxwell. Now what is Tesla? Tesla is a unit of flux density. Flux density. Tesla is a unit of flux density. There's one more unit is there similar to Tesla, that is Gauss. 1 Tesla equals 10,000 Gauss. This will be handy in your exam. So question number 18. In the induced EMF is maximum if conductor cuts the magnetic field at, the answer is option C, 90 degrees. So if this is the magnetic field and the conductor should cut in the vertical direction, then you will get maximum or EMF. Question number 19. Question number 19. In a series circuit, the current is. So what is a series circuit? Yes, see, we have a resistor here, we have a resistor here, then we have a battery here. Okay. In a series circuit, what happens? In a series circuit, if V is the potential, the same current will be flowing through all the resistors, irrespective of these values, maybe R1, R2, but all the same current will be flowing. Here also the current will be I. Here also the current will be I. Here also the current will be I. So in a series circuit, the current is same or constant. It is not proportional to each capacitor. Different in different capacitors. So we'll go to the next question. Question number 20. The previous question, let me see once more. In a series circuit, the same current will flow. That means the current is constant. Current is not going to vary. So the answer is constant only. Question number 20. Question number 20. The circumference of a circle is 66 mm. What is the equation for circumference of a circle? That is 2 pi r equal to 66. So pi r equal to 33. Now we have to find the diameter. We have to find. So r equal to 33 divided by 3.14. What it comes? What it comes? Let me check with the calculator. Here, no calculator, I think. So, okay. 33 divided by multiply 314. 314. So one time that is 314. 16. 160. 330 once. 160. 10 times. No, not 10 times. 0. That's going wrong. I will try and take the calculator. So where is the calculator? But you can't use calculator. So it is 333 divided by 3.14. 3.14, which equals to 10.5, which equal to 10.5, which equal to 10.5, which equal to 10.5. Now this is r. D equal to what? 2 times the radius, 2r, which equals to 10.5 multiplied by 2, which equals to 21 mm. So the answer is option A, 21 mm. Question number 21. A sine wave has a frequency of 50 Hz. Its angular velocity in radian per second. If you ask angular velocity or angular frequency, use the same equation. Omega equal to 2 pi f. What is 2? What is the value of pi? 3.14. What is f? F is 50 Hz. That's what he told. So it is 50 multiplied by 100. So 314. No, so it is 100. 3.14 equal to pi. So it is 100 pi. Answer is option D. Question number 22. The decimal number 29 in binary form is, so 29 we will divide it by 2, convert into binary form. So how many times? 14 times 28, remainder 1. Again we will divide by 2, 7, remainder 0. Again we will divide by 2, 3 times, remainder 1. Again we divide by 2. 1 will get remainder also 1. So it is, we got 29, 10 equals. Then we have to take like in this direction, we have to take it from bottom to top. 11101 to the base 2. Now if you check this answer whether it is correct or not, 1, 2, 3, 4, 5 are there. So we will start with 1 multiplied by 2 to the power 4. N minus 1 you have to start. 1 multiplied by 2 to the power 3 plus 1 multiplied by 2 to the power 4 plus 0 plus 1 by 2 to the power 0. So it is 2 to the power 4 equal to 2 to the power 4, 16 plus 8 plus 4 plus 1, 29. So the answer is correct, 29. The answer is option B, 11101. Question number 23. According to the Boolean algebra, according to the Boolean algebra, 1 or A and with 1 or B and with 1 or C can be simplified as. So we have 3 AND gates, 3 OR gates, 3 OR gates, sorry, 3 OR gates. So friends, we have 3 OR gates and 1 AND gate. See, in the exam, your success depends on how much you practice. Okay, you have to keep doing it. Then only it comes at the right time, it will be useful for us. So much practice, how much ever you practice, it is better. 1, B, and practice regularly. 1, C. See now this OR gate, if any one of the input of the OR gate is 1, output will be 1. All 1 will be coming here. So the output equal to 1. So the answer is option C, 24. Thermocouple works on the principle of, okay, thermocouple already I explained before. So thermocouple works on the Seebeck effect. Okay, so we'll go to the next question, 25. Question number 25. In an electronics or electrical circuit, in the angle between voltage and current is called, what it is called? It is called phase difference. That means this you take it as V. If you take it as I, there is a phase difference between them. That is almost 90 degree. It's almost 90 degree. So 90 degrees is the phase difference between voltage and current. What is a form factor? What is form factor? Form factor. What is form factor? The ratio of what? The ratio of RMS value to average value. It will come to 1.1. Peak factor. Peak factor. What is peak factor? Peak factor VM, that is the maximum value. Maximum value of AC to VM divided by root 2. That will give the root 2. This will give the RMS value. That is peak value to the RMS value. It will come to 1.41. That is the peak factor. What is the power factor? Power factor. What is power factor? Power factor. What is power factor? Power factor is equal to true power. True power divided by apparent power. That is apparent power. That is true power plus reactive fire. In impedance terms, R divided by Z. Question number 26. So guys, are you enjoying it? I don't think so you are enjoying it. We have to do a lot of hard work to get a proper job. So all of you keep trying, practicing it. After that you can enjoy. Question number 26. In a p-type semiconductors, the majority carriers are in a p-type semiconductor. The majority carriers are holes. Answer is holes. In an n-type semiconductor, it is electrons. Neutron doesn't come into picture. Now, question number 27. The period of a sine wave is period means t. T equal to 1 by 60. What is the frequency is asking? What is frequency 1 by t, which equal to 1 divided by 1 by 60, which equal to 1. We will take inverse and multiply 60 by 1. So it is 60 hertz. So the answer is option B, 60 hertz. Question number 28. The following is used as an active component in electronic circuit. What is used as an active component? First of all, what is an active component? Which supplies the source, the voltage source, current source, and transistor, FET, FET. These all are the active components. These components are active components. That means they generate energy, electrical energy. So the resistor, capacitor, and inductor, these are passive components. Passive. Also, these are linear components also. Linear. These are linear also. But all, okay, these are linear. Now, what is the question? Which of the following is used as an active component in electronic circuit? The answer is transistor. Question number 29. A rotameter is used to measure. Rotameter is used to measure the flow of liquids. So the answer is flow. 30. Area of a triangle having side 6 cm, 8 cm, and 10 cm. See this if we see this 6 centimeter, if we take square of 6 centimeter and 8 centimeter and root, we will get 10. Correct. 36 plus 64, 10 you will get. So it's a right angle triangle. It's a right angle triangle. So this I'll take it as 6, 8, and this will be 10. So we have to find the area. Area equal to half. What is the equation for area? Half BH, base into height. So these two values, if we interchange also, nothing happens. So 1 by 2 multiplied by B. What is the value of B? B here is 8. Base 8, height 6. Okay, so 2 times. Now 4 times. 6 4s are 24. 24 centimeters square, correct? Half, base is 8, height is 6. 4 times 4, 6 are 24. 24 centimeter square. So friends, I hope you like the video. If any suggestions, please mention in the comment section. If the videos are too long or how you want to be, or you want any particular topic, please mention in the comment section. If you have any doubt, you could WhatsApp me in the given number. So thanks for watching. Please share and like the videos. Thank you.